Hello friends, Namaskaram, Assalamu alaikum. Welcome to Edudemic. My name is NEHAS and today we are going to discuss about a new chapter in chemistry, that is carbon and its compounds. I hope you are all doing great. Now we are planning to divide this chapter, carbon and its compounds, into 4 sections. And in this first section we are going to talk about covalent bond. Now we are going to discuss this chapter, carbon and its compounds, on the basis of the reduced syllabus of 2020-21. So let us get into the video. Now before we are going to discuss about covalent bond, first let us talk about an introduction to carbon. We all know that what is carbon. Among all those 92 naturally occurring elements, carbon is the 15th most abundant in the earth crust. Right, it is the 15th most abundant in the earth crust. And the earth crust has some amount of carbon which is there in the form of minerals. Earth crust has 0.02% of carbon which is actually there in the form of minerals, like in the form of carbonates, in the form of hydrogen carbonates, and like coal, petroleum. These are some of the minerals of carbon. Let us see their pictures, like the carbonates, petroleum, coal. So these are some of the compounds which is made up of carbon, which is present in the earth crust naturally. Now whereas our atmosphere is also having carbon, our atmosphere has 0.03% of carbon dioxide. We all know that carbon dioxide's major constituent is carbon itself. Some can be in the form of carbon monoxide also. So we know that carbon is there everywhere, right? In spite of the small amount of carbon available in nature, carbon is having so immense importance. Let's talk about the food that we eat, like the vegetables, the fruits. They are all made up of carbon. Similarly, the paper, like the book which you are writing, the paper in that particular book is also made up of carbon. The meat, the cloth, even the cloth that we are wearing is made up of carbon. In spite of all these, we human beings are also made up of carbon. 18% of our human body is constituting of carbon. So we can say that carbon is so versatile that we will be able to find the presence of carbon from that particular simple lead pencil to a high-tech car body. If you see this particular tip of the pencil, it is made up of carbon which is there in the form of graphite. This tip is made up of carbon which is there in the form of graphite. Now, we can say that carbon is so important, but a question may arise in your mind, like how carbon is so important, or how carbon is able to make such a huge number of compounds that we are seeing even in our daily life. The answer for this, if you wanted to understand how carbon can form such a huge number of compounds, first we have to talk about the bonding of carbon. First we have to understand the bonding of carbon. So first let us talk about the bonding of carbon. See, a question for you guys is that can electrons be shared without actually being transferred completely? What does the question say? Can electrons be shared? Are we able to share the electrons without transferring them from one atom to another atom? So I hope that you may study the metals and non-metals chapter in chemistry. And if you don't, we will come up with that chapter very soon. Now, in that chapter, metals and non-metals, there is a kind of bonding that is called as ionic bonding. In ionic bonding, ionic compounds are formed by the means of ionic bonding. In this particular bonding, there is a transfer of electrons. In ionic bonding, a transfer of electron is taking place. So there is a transfer of electron from one atom to another atom. There is a kind of transfer of electron is taking place. Now, the question is like whether we will be able to share this electron without transferring them. Like we are not transferring the electrons, but we are sharing the electron. So, are we able to share the electron without transferring them is the question. The answer is that yes, we are able to share the electrons also without transferring them. Now, you may think how? Right, how electrons are shared without transferring them, and for that we have to talk about their bonding. Which type of bonding they are possessing? They are possessing covalent bonding. If the compounds are formed by transferring of electron, we can say they are covalent compounds. See, huge number of compounds are actually formed by the means of sharing of electron. We are sharing the electron. For example, consider a situation like sodium. Right, sodium is able to share one electron with another sodium, and they are sharing their electron. So when we are talking about sharing the electron, this means that compounds are formed by covalent bonding. Sharing of electron, always you have to remember, whenever we are sharing the electrons or compounds are formed by sharing electron, then that means it is formed, or that particular compounds are actually called the name known as covalent compounds. So covalent compounds are that compounds which are actually formed by the means of sharing the electrons. Now let us understand this covalent compounds, like how compounds are formed by covalent bondings. Let us find out that in much more detail. See, we know that nonmetals react with each other and they share their electrons. Let us see how. Let us consider an example of hydrogen. We are going to study about the sharing of electron in case of hydrogen. We are going to talk about the sharing of electron in the case of hydrogen. Okay, so we know that the some important terms that we have to know before we are discussing is like the duplet and octet. Now, duplet means to have two electrons in its outermost shell, and to have octet means to have 8 electrons in its outermost shell. Every elements are actually wanted to become octet, means to have 8 electrons in its outermost shell, but only the hydrogen is the only element which actually needed 2 electrons in its outermost shell to become stable. Now, why we wanted to have duplet or octet? In order to become stable and to have the electronic configuration of its nearest inert gas. Now, you may think why this, all these elements want to become duplet or octet. As I told you, in order to become stable, every elements have that tendency to become stable, either to have 2 electrons in its outermost shell or 8 electrons in its outermost shell. For this, they will either transfer or share the electron. So, we are going to discuss the sharing of electron in case of hydrogen atom. We are going to discuss the sharing of electron in case of hydrogen atom. Now the question is that how many electrons are required for this hydrogen atom to attain duplet? To answer this question, first we have to know the atomic number of hydrogen. Now, if you doesn't know how to find the atomic number of hydrogen, I have made already a video to how to remember the atomic number of any elements. So, I will put the link of that particular video in the description box below. So, please check that out. Now, let us come back to this. The atomic number of hydrogen is 1. So, we have studied in class 9th itself. If the atomic number is given, then how to write its electronic configuration? Right. So, here the electronic configuration is 1. Now, I told you that this hydrogen atom should attain duplet. Now, in order to become duplet, this should have 2 electrons in its outermost shell. But this hydrogen atom is now having only 1 electron in its outermost shell. Now, how many electrons are required for this particular hydrogen atom to have 2 electrons? So, it requires 1 more electron right? Then if 1 plus 1, it would have 2 electrons in outermost shell and it would become stable. So over here the answer would be B. It requires one more electron to become stable, to attain its duplet state, right? So it requires one more electron. So totally it will get 2 electrons. So we can say that it is stable. So for that particular to become stable and to attain duplet, this hydrogen atom would share its one electron with another hydrogen atom. See, we know that, let's take two hydrogens like this. We are having one hydrogen over here and one hydrogen over here. Now both of these hydrogen atoms should require one more electron to have two electrons. Now we know that this hydrogen's electronic configuration is 1. So it's in outermost shell, it would be having one electron. So if in its outermost shell, if there is one electron, we will just draw only one dot like this. And if the next hydrogen also, we know it would be having one electron in its outermost shell. So we will draw just one dot like this. Okay. And now we know we are talking about the sharing of electron, right? Now this hydrogen would just share the other electron from the other hydrogen. So this hydrogen get 2 electron, but this hydrogen also requires 1 electron, so it would take the other one also. So this hydrogen also get 2 electrons. So since you can see that they both are sharing the electrons, they are not transferring the electron, is not happening. They both are sharing the electrons. They are not transferring the electrons completely, but they are sharing the electron. So you can see that the total number of electrons being shared inside this bubble cloud is actually 2 electrons, right? How many electrons? 2 electrons. So whenever 2 electrons are being shared, we know that sharing is a covalent bond itself. But whenever 2 electrons are being shared, then we will call by a special name, that is single covalent bond. This is an example of single covalent bond. So in total, if 2 electrons are shared, then we will call it as single covalent bond. And this particular structure is known as the electron dot structure. It is known as the electron dot structure, and this is how we will draw the electron dot structure of any element. So for that we have to know the atomic number, and also we have to know how to write the electronic configuration. So since we know that atomic number, you can look at that particular video to know, and electronic configuration we have already learned in the 9th class. Now, as I already told you, whenever 2 electrons are being shared in total, we know that it is a single covalent bond, right? A single covalent bond. So you will just draw only one dash between them, you will be able to draw. So you will draw just one dash, right? So it is a single bond, and we know that sharing of electron means covalent bond itself, right? Now, let us see how the questions can be asked in the examination. Like this kind of way the questions can actually ask in the examination. So let us read the question first. Draw the electron dot structure of chlorine molecule. As I told you, first we have to know the atomic number. To draw the electron dot structure, the first step is to know the atomic number. Now we all know that the atomic number of chlorine is 17. So the next step is to write its electronic configuration. Electronic configuration. So the electronic configuration of chlorine molecule would be 2, 8, 7. The first shell the K shell can only hold maximum 2 electrons. The L shell, the next shell, can only hold maximum 8 electrons, and the remaining is over here. Right. So now you can see this is the electronic configuration. Now the third step is to find how many electrons are there in its outermost shell. You can say that in the outermost shell there are 7 electrons. Whatever is there in the last number in the electronic configuration, that is the outermost shell's number of electrons in its outermost shell. So we can say that 7 electrons are there in its outermost shell. Now whether it should gain, so we know that in order to become, how many electrons are required for this in order to become stable? It requires 8 electrons, but there is only 7 electrons. So it requires 1 more electron. So it requires 1 more electron to have 8 electrons in total. So it would share with the other chlorine molecules. So there are 2 chlorine like this. Now what would happen is that how many electrons are there in its outermost shell? 7. So we will draw 7 dots like this. 1, 2, 3, 4, 5, 6, 7. Similarly, other one also has 7 electron. Right, so we are drawing the 7 electron. Now, one hydrogen requires 1 electron. Similarly, the other hydrogen requires 1 electron. So, two of these, not hydrogen, chlorine. So, the two of these chlorine would have 8 electrons. Now, this chlorine would take 1 electron from the other chlorine, only 1 electron because it requires only 1 electron. Similarly, the other chlorine also would take 1 electron. So you can see that the first chlorine get 1, 2, 3, 4, 5, 6, 7 along with this 8. Similarly, this one also would have 1, 2, 3, 4, 5, 6, 7, 8. So you can see that total number of electrons being shared inside is just 2 electrons. So if 2 electrons are being shared inside, you can draw only one dash like this and you can say that it is a single covalent bond, and you will be able to draw just like one dash like this, okay, to represent single covalent bond. And this particular structure that you can see over here is nothing but the electron dot structure. Clear? Now let us move forward and discuss another case. See, now consider an example of oxygen. As I told you, first we have to know its atomic number. So oxygen's atomic number is 8. So its electronic configuration is 2, 6. Now, we can say that the question is how many electrons required for this oxygen atom to attain octet. Means to have 8 electrons in its outermost shell. But now in its outermost shell there is only 6 electrons. So it requires 2 more electrons. 2 plus 8 would give, so 2 plus 6 would totally give it 8 electrons, right? So in order to have 8 electrons in its outermost shell, it should get 2 more electrons, because at present the oxygen atom has only 6 electrons. So how many electrons are required to have 8 electrons? 2 more electrons, because 2 plus 6 would give us 8 electrons, right? So it requires 2 more electrons in order to have 8 electrons. So what would do? Similarly, the sharing of electron would happen, right? Because we are talking about covalent bonding. So this one oxygen would share 2 electrons with the other oxygen, and that oxygen also would share 2 electrons, like a reverse process, right? So you can see that each oxygen atom would actually share 2 electrons with another oxygen atom to complete its octet. So what would happen? Let us first write the atomic number. The atomic number of oxygen is 8. So its electronic configuration is 2, 6. So how many electrons are there in its outermost shell? So one oxygen's outermost shell would have 6 electrons, right? 1, 2, 3, 1, 2, 3, 4, 5, 6. Similarly, the other one would also have 6 electrons. Either you can draw cross or dot, okay? It's not a problem over there. Now let us draw the cloud structure. We know that one oxygen requires 2 electrons. So one oxygen would take just 2 electrons from the other oxygen. So it would have 1, 2, 3, 4, 5, 6, 7, 8. It has 8 electrons. Similarly, the other oxygen would also take just 2 electrons from the other oxygen. Now this oxygen also gain 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now you will be able to see the total number of electrons being shared inside of this is 4. Right, the total number of electrons being shared inside of this is 4. And you will be able to draw one dash like this and other dash like this. So whenever 4 electrons are being shared, then we will call it by another special name, that is double covalent bond. So this is an example of double covalent bond. So as I told you, whenever 2 electrons are being shared, it is single covalent bond, and whenever 4 electrons are being shared, then it is double covalent bond, right? So this particular thing is actually double covalent bond. So you can see that the total number of electrons being shared inside of this is 4. So whenever 4 electrons are being shared, double dash you have to draw, because between this you will be able to draw 2 dashes like this. So it's an example of double covalent bond. Now let us solve another question like this. A question of the water molecule. So whenever a large compound is given like water molecule, it's like the question is to draw the electron dot structure of water molecule. So whenever a large compound is given, then first try to write its formula. So the formula of water we know is H2O. Right, we require hydrogen also, and we also require oxygen. Oxygen also. Right. Now we know that hydrogen's atomic number is 1 and oxygen's atomic number is 8. So electronic configuration of hydrogen is 1 and electronic configuration of oxygen is 2, 6. Now how many hydrogens are over here? You can see that 2, H2O. So 2 hydrogens are there. So we'll write 2 hydrogens like this. And how many oxygen? Just 1 oxygen only. Now what we will be able to do is that let us draw its dot. Hydrogen's outermost shell has 1. But here oxygen's outermost shell has 1, 2, 3, 4, 5, 6. Now one hydrogen requires only 1 electron to have 2 electrons in its outermost shell, and one hydrogen also requires 2 electrons. But the complete oxygen requires 2 more electrons to have 8 electrons. So it would take just the 2 electrons from both of this hydrogen, and in this way in between the atom you can see that 2 electrons are being shared. Here you can see 2 electrons are being shared. Similarly over here also you can see 2 electrons. Between the atom we have to check. So you can be able to draw 1 dash like this and 1 dash like this. So you will be able to draw just like, so you will be able to draw only 1 dash between those atoms, right? Like 1 dash like this. So you can say that this is an example of single covalent bond. Right, here how many electrons are being shared? 2 electrons are being shared between the atom each. So like this the dashes would come, right? One single over there and single covalent bond over there. So you can see the structure of hydrogen also. That is, this particular one oxygen would take, one hydrogen would take just 1 electron from the oxygen. Similarly, the other hydrogen also would take just 1 electron from the oxygen, and the oxygen would completely take the 2 of the electrons from the 2 oxygen, and in between them you can see that 2 electrons are being shared. 2 electrons are being shared. So you can draw a single dash like this, right? So this is the electron dot structure of the water molecule. Now let us move forward and discuss another case of that of the nitrogen. Now nitrogen's atomic number is 7. So its electronic configuration is 2, 5. So you can see that in its outermost shell we are having 5 electrons. Now in order to have 8 electrons, how many electrons are it requires? In order to have 8 electrons in its outermost shell, it requires 3 more, because 4 plus 3 would give us 8 electrons. So in order to have 8 electrons in its outermost shell, it requires 3 more electrons. Now what would this nitrogen would do? They will share their electrons with other nitrogen, right? So 1, 2, 3, 4, 5, because 5 electrons are there in its outermost shell. 1, 2, 3, 4, 5. Right, now each of this nitrogen would require 3 more electrons, right? So this nitrogen would take 3 electrons from the other nitrogen. So it has 1, 2, 3, 4, 5, 6, 7, 8. Similarly, the other nitrogen would also take 3 electrons from the other nitrogen, and it has 1, 2, 3, 4, 5, 6, 7, 8. Now you can see that how many dashes are you able to draw in between? 1, 2, 3. And the total number of electrons being shared here is 1, 2, 3, 4, 5, 6. So whenever 6 electrons are being shared, then we will call it as triple covalent bond. So whenever 6 electrons are being shared, triple covalent bond. 4 electrons, double covalent bond, and 2 electrons, single covalent bond. So nitrogen is having triple covalent bond. Now let us solve one last question, that is to draw the electron dot structure of ammonia molecule. As I told you, the first method is that we have to follow is to write its formula whenever huge compounds are given. So you will be writing the formula NH3. Now we are having 1 nitrogen and 3 hydrogen, right? 3 hydrogen is the. Now we know that 1 hydrogen has 1 electron in its outermost shell. So each of them would have 1 electron in its outermost shell, and the nitrogen would have 5 electron in its outermost shell. So we can draw 5 electrons like this, 1, 2, 3, 4, 5. Now we can say that 1 hydrogen requires only 1 electron, so it will just share the 1 electron from 1 hydrogen. Similarly, like this, every hydrogen would have requires only 1 electron, so it would have 2 electrons. But the whole nitrogen requires 3 more electrons to have 8 electrons in its outermost shell. So it would take the other 3 electrons from 3 of these hydrogen like this, and they will share the electron, and all those atoms would become stable. And in between them, you'll be able to draw 1 dash like this, 1 dash like this, 1 dash like this. So 2 electrons are being shared in total in every cases. So this is an example of a single covalent bond like this. And the diagram that you can see over here is nothing but the electron dot structure of the ammonia molecule. Now let us see what is the difference in the properties of ionic as well as covalent compounds. Now let us differentiate on the basis of their properties of two of those ionic as well as covalent compounds. Now we know that ionic compounds are something which is formed by strong electrostatic force of attraction. Right, it is formed because of there are two charged particles, two charged electrons over there. Ions are there in the ionic compounds. So the force of attraction between them is so strong that it requires high melting as well as high boiling point to break such a huge attraction, right? Such a huge force of attraction. It requires that much heat to break such a huge bond. And it is also a good conductor of heat and electricity is because ionic compounds has the presence of free electrons in them. Ionic compounds has the presence of free electrons in them, and we all know that whenever there is a presence of free electrons, then we can say that it would be good conductor of heat as well as electricity because free electrons presence is there. All of these are the property of ionic compound. But when I am talking about the property of covalent compounds property is just opposite to ionic compound, because in the case of covalent compounds it would be having low melting as well as low boiling point, because a kind of small intermolecular force of attraction is there between its atoms. So low melting and boiling point, because in the ionic compound high melting, high boiling point, but covalent compound just opposite of ionic compound, low melting and low boiling point. This covalent compounds does not contain free electrons in them. There is an absence of charged particles that is same as free electrons is not there in the case of covalent compounds. Since in the covalent compounds there is no free electron, it is a poor conductor of heat as well as electricity. So this is the final conclusion slide. So please take a screenshot of this because it will be very useful for your exam. So the first point is that the covalent bonds are formed by sharing of the electron between two atoms so that both of them can achieve a completely filled outermost shell. And we know that the covalent compounds actually show an opposite property to that of the ionic compound, like low melting and low boiling point as well as poor conductor of heat as well as of electricity. Now let us talk mainly about carbon. Now let us focus for a few minutes in the case of carbon because the chapter is carbon and its compounds, right? So we are now mainly going to focus on the case of carbon. Now what is the atomic number of carbon? The atomic number of carbon is 6. So its electronic configuration is 2, 4. So you can see that there are 4 electrons in its outermost shell. So in order to become octet means to have 8 electrons in its outermost shell, it requires 4 more electrons. So since it requires 4 more electrons, carbon's valency is 4 and also the carbon shows tetravalency. Why we are saying that carbon shows tetravalency is because the word tetra means 4 And valency, we know the number of electron in its outermost shell. Since the number of electron in its outermost shell is 4, so carbon show tetravalency. Now let us understand carbon in much more detail. This particular thing that we are going to discuss right now is the problems related to carbon. Some of the problems that carbon is actually facing. See, since we know that the atomic number of carbon is 2, 4, we know that it requires 4 more electrons. Now, it can either gain 4 electron or it can either lose 4 electron, right, in order to become stable. But if carbon is trying to gain 4 electron to have carbon ion, it would not be possible because it is difficult for the carbon to gain completely that 4 electron. Why? Because we know that initially the number of protons we know that it is there in the nucleus. Initially the number of protons which is there in the nucleus would be 6 because its atomic number is 6. So the electrons would also be 6. That is over here. These are the electrons. Since the protons is 6 and electrons is 6, now when it is trying to gain 4 electrons, what would happen? The electrons would become 10. So this protons which is present in the nucleus would be difficult. You can see there is a huge difference in 6 and 10 numbers, right? So the protons which is there in this nucleus would be, it will found very difficult to hold such a 10 electron. It would be found it's so difficult to hold such 10 electron. Since it is found very difficult to hold such 10 electrons, it cannot hold them. So due to energy consideration as well as protons cannot hold such a huge, the nucleus is unable to hold such 10 electrons. So the carbon cannot gain 4 electrons. But when it is trying to lose 4 electrons, to remove this 4 electrons also, it requires that much large amount of energy to remove completely that 4 electron. Since it requires large amount of energy to remove completely that 4 electron, carbon can neither lose nor it can gain 4 electrons. So to overcome this problem, carbon actually shares its valence electron. And this is the reason why carbon is sharing, because carbon can neither lose nor gain electron. The carbon would share electron with other carbon atoms or with the atoms of another element, and they will form covalent bond. So we know that covalent bond is formed by sharing their electrons. So carbon is something which is formed by covalent bond. Carbon actually make compounds by forming covalent bond, by sharing the electrons, because it can neither gain nor lose the electrons. Understand? And we have already discussed that there are 3 types of covalent bond. The first one is single covalent bond, and I have already told that in single covalent bond 2 electrons would be shared in total, and double covalent bond 4 electrons would be shared in total, and triple covalent bond 6 electrons would be shared in total. So this is the all about the covalent bond. Let us take a recap slide. This is a recap slide or just the revising slide, that is carbon shows tetravalency. Why carbon shows tetravalency? Because of the presence of 4 valence electrons in them. And next, carbon cannot gain nor lose that 4 electron because of energy conservation. And we already talked about the thing that carbon forms covalent bond with itself and other elements by sharing those outermost electron. I hope you understand this chapter clearly, and if you have any doubts, you can write down in the comment section below. I hope that you found this video useful as well as awesome. If you do, please like and share, and please don't forget to subscribe to my channel, that is NEHAS Edudemic. We will come up with another section of the same chapter. Till then, take care and bye. Thank you.